So for this next part, it's going to be easiest if you have this piece of paper in front of you. Now, I know you've also got cards all over your table. My suggestion is, I'm just watching the time, I would encourage you to just pop your cards into one pile, unless you're like, no, I just finished the trick. Don't mess with my cards, okay? If that's the case, maybe just use a bit of other space. For the rest of you, though, you can actually put them to one side, and then we're going to work through this so that we can try and get the important information down. And I want to see if I can explain this to you, okay? So we're going to actually do this twice, and you'll see why we do it twice in a minute. It's actually very important we do it twice. This first method, if you want to fill it in, you can see I've got this, I'm a big believer in spoiler-free worksheets. I hate it when I go to the movies and someone's like, oh, that's the bad guy. I'm like, I hate it when people spoil movies. Yeah. That's why it's not very descriptive. We're going to call method 1 numerical. Because what we're going to do is we're just going to start doing a bit of counting of the numbers and see what that will teach us, okay? Now, you can see this table kind of has 4 spots that you can put in working. We're just going to put some big numbers there, actually. Piles 1, 2, 3, 4, I've kind of numbered them in the order that they appeared. Those ones down the bottom, which color did we have over here on the left? Black. These are the blacks. Okay, so I'm just going to say black, and then I'm also going to say these are face up. And then over here on the other side, that's where we had the red cards. And they're also face up. Okay. Pile 3 and pile 4, they're kind of, I'm actually just going to put a question mark there because the whole point is we actually don't know what those are, and we'll come back to those shortly. All right. Now, hey sir, did you want...
Can I grab Jack for a couple of minutes? Is that okay?
Yeah.
Okay.
No worries. Okay, now, no problem. Now, before I start to write down numbers, okay, this is the numerical approach. You might recall we had our 4 piles of cards when we first performed the trick. Now, I was listening as I wandered around as you guys were doing this, right? I heard a really good hypothesis, a really good conjecture, which was that there are 52 cards, and originally we made 4 piles. 52 divided by 4 is 13. So a really good hypothesis or conjecture is there might be 13 cards in every one of the, let me just put it back there, in every one of the 4 piles. It's a good idea. Sometimes it's true, but often it's not, and I'll show you how I know. This is the first time that I performed the trick that you can see here, right? So I'm just going to count. You may actually remember this happening. I don't have 13 cards over here on the left-hand side. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Not close to 13 at all, far fewer. And you may remember the reason why. It's because at a certain point, like right near the start, I had this huge streak of red cards. And I was like, I'm hoping I'll get a black card eventually, if anyone noticed that. So because I had a long streak of red cards, I just ended up with more red cards over here. You can see it's many more than the 9 black cards I have on the other side. Now, I said it was a good idea, it was a good hypothesis. You're like, but Mr. Wu was wrong. Yes, but wrong ideas are very important to pursue in mathematics because if you don't pursue them, you don't know which ones are right, okay? So here's what I'm going to do. Even though your numbers may be slightly different to mine, I invite you to follow along with me that I now know there are 9, oops, I used the wrong one, 9 black cards here. Now, remember I showed you all of those red cards that I had. If I wanted to, I could just physically count them out. But I don't need to. We can use our mathematical glasses to see that I can actually work this number of red cards out without any counting at all. Some of you can tell me how many cards there should be over here on the right-hand side in my situation. Any takers? Go ahead. 17. Come and write 17 with me and think about why. What was your name, sorry? Isha. Let's work out how Isha knew. Like, she's not anywhere near my cards, right? Where does the number 17 come from? Any takers? Yeah, go ahead.
26 minus 9.
All right, so 26 take away the 9 on the left gives you 17, but then that asks the next question, why 26 take away 9? What's the significance of 26, Jack?
Because there has to be 26 in each 2 rows.
Okay, fantastic. So
every one you put down, you put another one down.
very good. So these are the face-up cards here, right, in the bottom half. Every time you placed a card down the bottom here, you paired it or you matched it with a card up here. So 1 up, 1 down, 2 up, 2 down. Eventually, once you finish the whole deck, it'll be 26 down, the 26 we've counted, and 26 up on both sides. Make sense? All right, I promised that we would return up to these mystery cards up here. Now the thing is, there's actually kind of 2 piles in each pile, right? Because some of them are black, some of them are red. Now we already know, because we counted them when I first performed the trick, that there are, I think it was 5. Was it 5? Black cards over here, right? Now, we could then go over to the end. I said, ooh, look, I hope there are 5 red cards over here, which was a bit facetious of me. I already knew there were going to be 5 red cards because I know how the trick works. But before we hurry over to there, think with me about this mystery number in here. This is the number of red cards. We didn't count it when we performed the trick, but again, if you're thoughtful with me, you can work out how many red cards there are without counting. How many? Say it louder.
4.
There are 4. How did we know that there were 4? Yeah, go ahead. Fantastic. It's the pairing again, isn't it? The 9 cards here correspond to or are symmetrical to the 9 cards here. Are you following? All right, now, we are so close. Have a look at the screen really carefully. How many red cards, this is not a trick question, how many red cards have I currently accounted for? You can say it all aloud to me. It's 4 plus 17, which is 21, right? But before we even began the trick, you know that there are how many red cards in an entire deck? There are 26. So 26 take away those 21 leaves you with the 5 that I revealed at the end. It has to be, there's no other way, okay? Now, I did promise we're going to look at this a second, like there's going to be a second method, which will go a bit faster, you'll see why in a second, but the astute among you, the observant, will have noticed there's a part of the trick that I haven't explained yet. Does anyone remember? Which part of the trick have I not talked about yet? I got Annabelle to help me with it, remember? It was the swap, wasn't it? Okay. Now, what I just explained to you and what we've all written down should tell you that actually our swap that Annabelle helped us do, what difference does it make to the numbers of the cards? It doesn't make any difference, right? I just wrote down all of those numbers, not talking about the swaps at all. So the swaps didn't muck around with it one bit. So that leads to the next question, which is, why not though? Like, shouldn't they have changed the situation somehow? Do you have a theory?
There's a fixed number of black and red cards, and because we already established that we've subtracted some red and black cards, so the remaining at the top must be always the same.
Mm-hmm.
When you change it, you don't change anything other than the fact you're just changing the general number.
Okay, very good. So if you didn't quite follow that logic, right? It's about the fact that we have 26 black cards and 26 red cards. So let me see if I can illustrate that same logic, but just do it with the actual cards, okay? I'm going to do this in super slow motion, just so that you tell me when to stop, okay? Annabelle told us to do 3 cards, right? But in mathematics, when a problem is complicated, like a classic problem-solving strategy is we look at a simpler version of the complicated problem and see if our understanding can help us there, okay? So instead of swapping 3 cards like we did the first time, let's just imagine swapping 1, okay? Now, for the sake of illustration, I know it's going to look silly, but just follow me, okay? Suppose that the 1 card that I chose on both sides was, by chance, a red card on both sides. And then I swapped them. Not a rhetorical question. How have my numbers changed at this point? They haven't, right? Because 1 red just became another red, no big deal. Hopefully you don't need me to actually do it to prove that to do the same with the blacks. If I swapped a black card for a black card, again, no change. What's really interesting is if the colors are different. Watch really closely, okay? I'm going to do it in slow motion. You tell me when to stop. Here goes the black card. I'm going to swap it over to the other side. There are no longer 5 black cards here. There are now 4. Yeah? And now I'm going to finish the swap. Here goes the red card. There are no longer 5 red cards over here. There are 4. And so as this reduces in 1, so does the other one. And in reverse, if I'd gone the other direction, they'd go from 5, 5 to 6, 6. And that's why no matter how many times we all do the trick, we all did it simultaneously, we all end up with this same symmetry. Does that make sense? Okay, let's finish this out, because the topic you're currently in is the reason why I showed you this trick. Does anyone know what topic you're in? It starts with an A.
Algebra.
It's algebra, right? We're now going to do this not numerically, we're going to do it algebraically. Okay, and even though you're like, Mr. Wu, you only left 4 minutes to do this, it's actually going to go much faster than the other one, right? Algebra is just the kind of maths you do with numbers that can change. And that's exactly the situation we're in right now, right? Every single one of you did the trick slightly different to me, and your numbers modified as you went. That's why we have variables, okay? So instead of writing, for example, that there's 9 black cards over here, they're black cards. So what pronumeral would you choose for black cards? How about B for black, okay? Very original, right? So here are the black cards. Now, let's rehearse that same logic that we used when we were going through here, right? If I wanted to, I could go over here and I could say, oh, these are the red cards. Let's call it R for red, but hold on. It's actually not a separate independent number. It's related to B. You guys told me that there would be 17 over here, and you knew it from this 9. How did you do it again? You went 26 take away 9. Now, instead of 9, I'm going to say B. 26 take away B. Okay. Now, remember how I did the trick and I got up here, sorry, I'll just zoom out so you can see, I got 5 and then 5, but you didn't have to get 5 and 5. Some of you got 7 and 7, some of you got 10 and 10, all different kinds of combinations. So this number can also change. So being that this special important number can change, let's call it X. This is often the name we give to like the special number, right? Now if this is X, and then that's the number of, whoopsie daisy, sorry, the number of black cards over there, I then said we could work out this number of red cards in here. And you all could tell me that it was 4, but where did we get 4 from? Have a look carefully, yeah. Yeah, 9 take away 5 gave us 4. So follow the logic. Down the bottom here, it's not 9, it's B. And instead of 5, it might not be 5. In fact, in your case, it wasn't 5. So it should be B take away X. Okay, let's jot that down. And these are red cards as well, so I'm going to write it in red. B take away X. And at this point I said, now, how many red cards have we accounted for? And you told me, looking at the 4 and the 17, you said it was 21. But now suddenly, I've got all this to contend with, right? Like, this is the number. I'll highlight it in green for you. This is the number of red cards that I've counted. The only problem is, it can change based on what B is and what X is. How did you use 26 and 21, don't move, I promise I'll be quick, to work out 5? What did I do? 26, take away the 17 and the 4, right? The 17 and the 4. Do you agree with that? Yep. That gives you 5. Okay, down here, I'll zoom out so I hope you can see it, right? It's going to be 26, take away 26 take away B, that's my 17. And I'm also going to have the B minus X. That's the 4. Did you see that? Yep. That's the 4 right there. Okay. So watch what happens. Isn't it lovely? There's the 26s, they cancel. What happens to those B's? They cancel. And then you've got, watch it carefully, there's a negative there and a negative there. What do? They become positive and they leave you with that X just like you started. Year 8, I hope you learnt something of algebra and its power out of that. Have a fantastic afternoon.